Today's topic is special trig limits. So memorize these two special trig limits. I have another video of proof of these two special trig limits. Limit theta approaches 0, sine theta over theta is equal to 1. Limit theta approaches 0, 1 minus cos theta over theta is equal to 0. So these are very handy and useful, and these can be in different forms as well. You could also see limit theta approaches 0, theta over sine of theta. That would be also equal to 1 because you can do the reciprocal on both sides. Or another form, we can see the second trig limit is cosine theta minus 1 over theta. That would be still equal to 0. Let's see some examples. The third special trig limit is cosine theta less than equal to sine theta over theta less than equal to 1. So sine theta over theta is squeezed between cos theta and 1 as long as we're between negative pi over 2 and positive pi over 2, and theta is not equal to 0. So here's an example. Limit x approaches 0, sine 2x over 3x. So we just saw that limit theta approaches 0, sine theta over theta. So we have to have the same angle, same argument in the numerator. Then we have to have the same thing in the denominator. The argument from the numerator has to be in the denominator. So sine 2x, if I have sine 2x in the numerator, I must have 2x in the denominator, then that limit would be equal to 1. So I'm going to separate the 3 in the front. I'm going to isolate the 3x, write it as 3 times x. And now I'm going to multiply and divide by a 2. So that I have the same argument, whatever is the argument in the numerator, I have that as my denominator. So limit, I'm going to call it x equal to 0, not theta, because in this problem we're given x equal to 0. Any angle, this would translate. So limit theta approaches 0, 2 over 3 sine 2x over 2x. This limit goes to 1. So my limit is going to equal 2/3. Okay, the limit here is going to equal 2/3. Next, we have limit theta approaches 0, sine square x over x. Okay, so in this case, we have limit x approaches 0, sine square x. So I'm going to break it into sine x over x into sine x. All right, so sine x over x, this limit goes to 1. We know that. And limit x approaches 0, sine of x, this limit goes to 0. 1 times 0 is going to be 0. So my limit goes to 0. In this video, we're only going to look at trig limits, the limits involving trig functions. Tangent 3x over sine 5x. Okay, so let's go ahead and split them. We have tangent 3x, so I'm going to write it as sine 3x over cosine 3x. And I'm just writing them as with the product. And now we can go ahead and do limit x approaches 0, sine 3x times 1 over sine 5x times cosine 3x. Okay, so I'm going to multiply and divide with an x. Now I'm going to multiply and divide with a 3. And I'm also going to multiply and divide with a 5. The reason why I did that is now I can see my special trig limits. And I can just leave a 1 in the numerator for cosine 3x. This limit goes to 1. This limit goes to 1. When x approaches 0, cosine of 3x will be cosine of 0, which is also equal to 1. So this limit turns out to be 3/5. And 3/5 is going to be my final answer for this limit. We earlier saw the squeeze theorem in a different video. Next example, we have tangent 4t over t secant t. So let's go ahead and break the tangent 4t. Sine 4t over cosine 4t times 1 over t. And secant is 1 over cosine. If I have secant, 1 over secant will be cosine. So I'm writing 1 over secant as a cosine of t. Okay, now again, a little bit shuffling, moving things around. Sine 4t divided by t times cosine t over cosine of 4t. Okay, so one quick thing, because my argument is 4t, I need to have 4t in the denominator. So I'm multiplying and dividing by a 4. If I do that, then this limit will go to 1 as t approaches 0. And cosine of t over cosine of 4t as t goes to 0, this will be 1 divided by 1, which is equal to 1. and this entire limit will be equal to 4. Next, we have square root of t cubed plus 9 times sine t over t. Okay, so limit t approaches 0, we can isolate sine t over t times t cubed plus 9. So what is going to happen to this limit? We know sine t over t, as t approaches 0, this limit is going to go to 1. And square root of t cubed, when t goes to 0, that would be just square root of 9 times 1, which is going to be equal to 3. Okay, a couple more examples. Limit t approaches pi over 2, 1 minus cosine t over t. Now, keep in mind, this is not your special trig limit because t is not going to go to 0. T is going to pi over 2. So, let's see what's happening here. 1 minus cosine pi over 2 divided by pi over 2. What is cosine of 90 degrees? Well, sine goes from 0 to 1. Cosine goes from 1 to 0. So cosine goes from 1 to 0. 1 minus 0 over pi over 2, and that's going to be 2 over pi because this is 1 over pi over 2. When you simplify, that's equal to 2 over pi. Next, we have theta approaches 0, secant theta minus 1 over theta. Well, it doesn't look like special trig limit to me right now, but let's go ahead and simplify and write secant as 1 over cosine theta minus 1 over theta. Limit theta approaches 0. Cosine theta, 1 minus cosine theta over theta. So limit theta approaches 0, 1 minus cos theta over theta times cos theta. That's what we're left with. Now what we can do is we can go ahead and break this apart into, this would be limit theta approaches 0, 1 minus cosine theta over theta times 1 over cosine theta. Now we do know that this limit goes to 0. And 1 over cosine of 0 is 1. 0 times 1 would be 0. So this limit goes to 0. Next, we have sine of negative 3 theta. We do know sine is an odd function. So if you have a negative inside a sine function, you can pull it out. And I can write it as, I can pull the negative all the way out, negative 1. This becomes sine 3 theta over sine 4 theta. So negative outside, limit theta approaches 0. I'm going to separate them. So now I'm going to multiply and divide with a theta. If I multiply and divide with the same thing, I'm not really changing the fraction, so I can do that. Now I'm going to multiply and divide with a 4. I multiplied and divide with the 4. Now I'm going to multiply and divide with the 3. This is going to help me because I see these two limits are going to go to 1 and we'll be left with negative 3/4, and that's going to be my limit in this case. That's where I'd be left with. Next, we have limit h approaches 0, 1 minus cosine of h over h squared. So in this case, we can rationalize. Limit h approaches 0, 1 minus cosine of h over h squared. So we can do 1 minus cos. This is going to be 0 over 0, and that is the trouble. The 0 over 0 is going to be an issue here. Let's see. Come back to it in a minute. Let's look at the rest of the problem. Sine 3x over sine 2x over x times sine 5x. So we have sine 3x sine 2x over x sine 5x. Limit x approaches 0. So I'm going to isolate these. Limit x approaches 0. And then I have sine 5x in the denominator. I already have an x here. I'm going to leave that over here. Now I'm going to multiply and divide with an x. So I can multiply and divide with the same thing, and that doesn't really change anything. Now, sine 3x. Okay, so we do need to have the same, whatever is the argument in the numerator, we need to have the same thing in the denominator. So multiplying, dividing by 3, divide by a 2, same thing as multiplying by 2. So multiply with a 5 and divide with a 5. And now we can see all these limits are going to go to 1. So 6 over 5 is what the limit looks like, is going to turn out to be 6 over 5. All right, next we have cosine t minus cos squared t over t, limit t approaches 0. Looks like I can factor out a cos t from here. Limit t approaches 0, cosine t, 1 minus cosine t over t. Limit t approaches 0, we can separate cosine of t times 1 minus cos t over t. We do know that this limit goes to 0 when t goes to 0, and this limit goes to 1. 1 times 0 is going to be 0, and that would be my end product. That's going to be my limit here. We'd be left with 0 here. Okay. Next we have number 14, and sine 2h over 1 minus cosine h over h. So let's go ahead and isolate limit h goes to 0, sine 2h divided by h times 1 minus cosine h divided by h. Okay, so we know when h goes to 0, this limit goes to 0, and we can multiply and divide by 2, and this limit goes to 1. 2 times 1 times 0 would be simply equal to 0. Now we have 1 minus cosine 2t divided by t. Limit t goes to 0. Well, we have to have the same argument that we have in the numerator, so we can multiply and divide by a 2, and now we know this limit goes to 0, so we would be able to say 2 times 0 is 0, and the limit goes to 0 in that case. We already saw squeeze theorem in a different another example of squeeze theorem. So here we have cosine 2 theta minus cosine theta. So how do we handle cos 2 theta minus cos theta? So we can maybe write down cos 2 theta as cos squared theta minus sine squared theta. Let's go ahead and give it a try. So cos 2 theta is cos squared theta minus sine squared theta minus cosine theta over theta. Okay, so I'm gonna isolate. All right, so what I'm gonna do is I'm gonna write it as still the limit theta goes to 0, limit theta goes to 0, cos squared theta minus cosine theta over theta minus sine squared theta over theta. Okay, so we can factor out from here. I can pull out limit theta goes to 0. Or we can have cos theta minus 1 over theta minus sine square theta over theta. Okay, so we know this limit, because cos theta minus 1 over theta goes to 0, 0 times 1, so this would be 1 times 0 minus sine theta over theta is 1 times 0. Sine theta over theta is 1, and sine theta will be 0. So 0 minus 0 will be just 0. This limit is going to go to 0. Now we have 1 minus cosine 2h over sine squared 3h. So how we can handle 1 minus cosine 2h? I need to have 2h in there. And then, okay, let's break cosine 2h. Cosine 2h, I can write it as 1 minus sine squared 2h. Sine squared 3h. Okay, 1 minus, we still have limit h goes to 0. Do not drop the limit. Limit h goes to 0. 1 minus 1 plus sine squared 2h over sine squared 3h. Now this has made my life a lot easier because I can just go ahead and cancel, get rid of these two. Get rid of these two, and we can see limit h approaches 0, sine squared 2h over we can write them separately. Limit h approaches 0. Limit h approaches 0, that would be sine 2h times sine 2h. I need more space. Limit h approaches 0, sine 2h times sine 2h, 1 over sine 3h times 1 over sine 3h. Now I'm going to multiply and divide with sine 3h. I'm going to multiply and divide with an h. Okay, so I'm dividing with an h, multiplying with an h, dividing with an h, multiplying with an h. I need to have a 2 here, so I'm going to divide with the 2. I need to erase a part of the other problem to give myself a little more space. Alright, so and this was limit h approaches 0. This was limit h approaches 0. So we are dividing by 2, multiplying by 2, dividing by 2, multiplying by 2, multiplying by 3, dividing by 3, multiplying by 3, dividing by 3. That turns out to be 4/3. And did we have a negative here? No, and that was just for the limit. So this limit turns out to be 4 over 2 times 2 is 4, 3 times 3 is 9. 4 over 9 is what the limit turns out to be. Okay, so we this is not correct. 1 minus 2 sine square 2h. Erase. There's a small typo here, and that messed up the whole thing. That's not right. Okay, let's look at it one more time. I didn't use the trig identity correctly. I put a 2 at the wrong spot. 1 minus cosine 2h is 1 minus 2 sine square h. Okay, so let's fix that. Limit h approaches 0, 1 minus 2 sine, there's a 1 minus, and then 1 minus 2 sine square h divided by sine square 3h. Okay, so limit h approaches 0, 1 minus 1 plus 2 sine square h divided by sine square 3h. All right, now we can see the negative 1 and positive 1 is gone, and this is going to be limit h approaches 0, 2 sine square h divided by sine square 3h. Now we can isolate limit h approaches 0. I can pull the 2 out. Sine h times sine h times, and then we have sine 3h, sine 3h. Now I'm going to multiply and divide with an h, multiply and divide with another h. We know these two limits are going to go to 1, and we need to have a 3 here and a 3 here, so divide with the 9 as well because we multiplied with the 9. And these limits also go to 1, so this is going to be 2 over 9. Okay, that's going to be 2 over 9. And that's going to be all for this video.